Good evening.
Good evening, sir.
Only one participant. Maybe I'll wait for a couple of minutes. Few others will join. Am I audible?
Yes, sir.
Okay. So we'll wait for some time because only you have joined now. Others, maybe few others will join. Then we can start maybe. Two, three join, then we can start.
Yes, sir.
Okay.
ସାର୍ ଆଉ କେହି ଜଏନ୍ ହେବେନି ବୋଧେ।
Is my screen visible to all of you? Am I audible?
Yes, sir.
Is my screen visible?
Yes, sir. No, 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 sir, no, sir. Only photo.
Okay, let me see. Screen ଦିଶୁଛି ଏବେ?
Yes, sir.
So whatever I am writing, you are able to see, right?
ଆଜ୍ଞା ସାର୍।
Okay, good.
ସାର୍ ପୂର୍ବ କ୍ଲାସଟା ହେଇଥିଲା ସାର୍।
ପୂର୍ବ କ୍ଲାସଟା
ସାର୍ କେବେ ହେଇଥିଲା ସାର୍?
ପୂର୍ବ କ୍ଲାସଟା ଶୁକ୍ରବାର ହେଇଥିଲା।
ଆଜ୍ଞା ସାର୍ ମୋ ସାର୍ ଲିଙ୍କଟା କାମ କରୁନଥିଲା ତ ମୁଁ ଭାବିଲି ବୋଧେ ଆଉ କ୍ଲାସ ହଉନି।
No, ଶୁକ୍ରବାର ହେଇଥିଲା ନା। Hmm. Somehow my screen is not getting shared. Just let me try again. ସ୍କ୍ରିନ୍ ଟା ଦିଶୁଛି?
ଆଜ୍ଞା ସାର୍ ଟିକେ ନେଟୱାର୍କ
You can see the PDF, right?
ସାର୍ ସ୍କ୍ରିନ୍ ଦେଖାଉନି।
ଦେଖାଉନି?
ନାଇଁ ସାର୍।
I don't know what is the problem today. Okay, give me 2 minutes. I'll try to fix it. ହେଲା। Good evening.
Good evening, sir.
Is my screen visible to you?
Yes, sir.
So whatever I'm writing, it is visible to you, right?
Yes, yes, sir.
Okay.
Transformation property of angular.
Yeah. So transformation property of angular momentum under parity.
Yes, sir.
Okay. So angular momentum, as we know, L is equal to R cross P, right? And
Yes, sir.
this angular momentum operator has three components, Lx, Ly, and Lz. Okay.
Yes, sir.
From quantum mechanics 1, you know that your Lz, z component of the angular momentum, is basically equal to ypz minus zpy, isn't it? Now we are interested what happens to this angular momentum, or at least the z component of angular momentum under parity. Under parity transformation, what will happen to it? So parity transformation, that will be uh, just a second, phi dagger Lz pi. Okay, so that will be equal to what? Phi dagger Lz is what? Y pz minus z py pi. Okay, so with that in mind, if we open the bracket, so that will be pi dagger y pz pi minus pi dagger z py pi. Okay, now what we'll do there, here I can write pi dagger y, these are operators, huh? These are all operators. Y, here I will introduce an identity operator. Identity can always be multiplied, right? So y pz pi minus similarly pi dagger z identity py pi. Okay, this is pi dagger y. I can write pi dagger. Okay, since pi is a unitary matrix or unitary operator, I can simply write that pz pi minus similarly pi dagger z identity I can write pi dagger py pi. So if I simply pi dagger y pi into pi dagger pz pi minus pi dagger z pi into pi dagger py pi. If I write like this, all right. So what is pi dagger y pi? Pi dagger y pi. What is that? Minus y, right? Because what exactly parity does? Last class we have discussed. It will go to minus y, and this will go to minus pz. Okay.
Yes.
Uh, and what will it be? Sorry, sir. I have to make a correction over here. Should be Lz is ypx. and xpy. I got it. Ypx xpy. Similarly, here it will be py x just sticks. Hmm. So similarly, ypx minus this will be minus x, and this will be minus py. So this will be ypx minus x py. Okay,
Yes.
so that is basically equal to Lz again. All right. Now, similarly, similarly, we can write pi dagger Ly pi would be equal to Ly pi dagger Lx pi would be also equal to Lx. So what does it do? With these three conditions, or if I summarily write Lz pi is equal to Lz. Well, let us take this equation. Okay. So so pi dagger Lz pi is equal to Lz. This implies pi dagger Lz pi is equal to pi Lz. I multiply pi on the left.
Pi on the
This will
right.
be equal to identity Lz pi minus is equal to pi Lz, or pi Lz minus Lz pi. Hmm?
Yes.
This
Yes.
pi minus pi Lz is equal to 0. This implies Lz pi commutator is equal to 0, isn't it?
Yes.
So what does this mean? That means the parity operator commutes with Lz, right? So similarly, I can write similarly Lx pi commutator is equal to 0. Ly pi commutator is equal to 0, isn't it?
Mm. Yes.
So the parity commutes with the x, y, and z component of the angular momentum. Okay. Similarly, you can show that parity also commutes with the x, y, and z component of spin angular momentum. This is orbital angular momentum basically. Angular momentum means this is orbital angular momentum. Similarly, you can also show that it will commute with spin angular momentum and commutes with. Okay. Now, with these two in mind, total angular momentum, which is basically equal to L plus S, right? Orbital angular momentum plus spin angular momentum. So the same property will hold good. So that is why your uh, parity will basically commute with total angular momentum. Parity will commute with total angular momentum. Okay. So what is the meaning? What is the meaning? Suppose I have two operators. A, B commutator is equal to 0. What does this mean? What is the meaning of this one? What is the physical meaning of A, B commutator bracket is equal to 0?
ମୁଁ ସାର୍ କହିପାରିବିନି।
See, when, okay, let me give other example. What is the value of uh, y, sorry, y commutator? What is the value of this? X operator, Y operator. X is X position, Y is Y position. What is the value of the operator? Commutator bracket?
ଜିରୋ।
0, right? XY is equal to 0. So that means both X and Y, because each operator will correspond to some physical quantity. That's what quantum mechanics says, right? For each physical quantity, we will have an operator. So two operators commute with each other. That means these two physical quantities can simultaneously be determined. These two physical quantities can simultaneously be determined. What is X Px commutator? No, sorry, this is not 0. What is the value? X Px.
XPX। नो सर।
This is IH cross. You remember from quantum mechanics 1, X Px is equal to IH cross. So that means that's where your uncertainty principle comes, right? That both X and Px, position and momentum, cannot be simultaneously determined accurately. Okay. So that means XPX commutator is not equal to 0, rather it is equal to IH cross. That is why you are getting this delta X into delta PX of the order of H cross, right? That's what you get. So delta X into delta PX is of the order of H cross or H cross by 2, doesn't matter. H cross is a very small quantity anyway. Getting my point? So if the commutator is 0, that means if the commutator is 0, that means those two physical quantities can be determined simultaneously. Okay. So now what exactly from parity operation, what exactly we are getting is like your Jx phi commutator is equal to 0, Jy phi commutator is equal to 0, Jz phi commutator is equal to 0. So that means x component of total angular momentum, y component of total angular momentum, and z component of total angular momentum are basically equal to 0. So total angular momentum and parity, they can be determined simultaneously. They can be determined simultaneously. Okay.
यस सर।
Yeah. So the transformation which you should remember. Let me write down that four transformation position for position operator. Except for position operator, uh, x cap. What is it? So phi dagger x phi is equal to minus x. for position operator. For momentum operator, momentum operator here, pi diagram px pi is equal to minus px. Okay. Third
Yes.
one is orbital angular momentum. Orbital angular momentum. Let's say Lx. That will be pi diagram Lx pi is equal to simply Lx, not minus. So similarly, total angular momentum Jx. So pi diagram Jx pi is equal to Jx. Okay.
Yes.
And if I take for that matter spin angular momentum, Sx pi diagram Sx pi is equal to Sx only. Okay.
ସାର୍ ଏଇ ଦୁଇଟି
So
ମାଇନସ୍ ଆଉ LX JX ପଜିଟିଭ୍ କାହିଁ ରହିଲା?
that we calculated, right? We calculated here Lx ଟା Lx ହିଁ ହବ ଆମେ କାଲକୁଲେଟ କଲେ ବା LZ ହବ ଏଠି ଆମେ କାଲକୁଲେଟ କରିଥିଲୁ pi diagram LZ pi is equal to LZ, right?
Z. Yes.
So similarly, pi diagram Lx pi will be equal to Lx, pi diagram Ly pi will be equal to Ly. ବୁଝିହେଲା?
Yes, sir.
But minus parity usually what parity does? Parity usually inverts, right? Parity ମାନେ କଣ? What is parity? Parity means you go from x, y, z to minus x, minus y, minus. So usually it inverts. But in case of uh, angular momentum, orbital angular momentum, total angular momentum, or spin angular momentum, it does not invert. It keeps it same. Okay.
Yes, sir.
So when things, I mean, when the quantity does not change its sign, it is called even parity. So you can say orbital angular momentum, total angular momentum, spin angular momentum, they do not change any sign, right? So when a minus one.
Hmm.
So
Yes.
these quantities are even parity or even under parity transformation. Okay. So
Yes.
even parity is Lx, Jx and Sx, but odd parity, odd parity will be X and
P.
Px, right? Ready?
Yes.
Okay. Let me go to the Yeah. Okay. So I suggest you to go through page number 40, 42, 43, and 44. Okay.
Yes, sir.
And if you have any questions, you can ask me. Take maybe 5-10
Okay.
minutes. Go through it.
Okay.
If you have any question, you can ask me. Else, I'll move over to the next part.
Okay, sir.
Okay. 42,
Yes, sir.
43, and 44. Okay.
Yes, sir. Yes, sir.
ବୁଝି ହଉଛି?
ସାର୍ ଏଠି ଯୋଉ ଆରପି ଦେଇଛି ସାର୍ ଏଟା ଆରପିଟା ଗୋଟେ ଆଇଡେଣ୍ଟିଟି ମ୍ୟାଟ୍ରିକ୍ସ କନସିଡର କରାଯାଇଛି।
No, no, no. What is given RP? କଣ ଲେଖା ହେଇଛି RP? RP ଟା କଣ ଲେଖା ହେଇଛି?
So in three dimensional space जो parity of ट्रांसफॉर्मेशन को गोटे वेक्टर फॉर्म रे कंसीडर करा जाइछि r डैश
ହୁଁ
वेक्टर
ହୁଁ
rp इज
ତେଣୁ
r
ତେଣୁ
वेक्टर
ଆମେ ଯୋଉ ଲେଖିଲୁ x y z will go to minus x minus y minus z, right?
माइनस z yes sir
So ସେଟା ଆମେ ପାଇବା କେମିତିଆ? That means x prime is equal to minus x, y prime is equal to minus y, and z prime
yes
is equal to minus z.
माइनस z
ତାକୁ ଯଦି ଆମେ ଗୋଟେ ମ୍ୟାଟ୍ରିକ୍ସ ମଲ୍ଟିପ୍ଲିକେସନ ଫର୍ମରେ ଲେଖିବା ତାହେଲେ ସେ ଯୋଉ ଟ୍ରାନ୍ସଫର୍ମେସନ ମ୍ୟାଟ୍ରିକ୍ସ ଟା କଣ ହବ? The transformation matrix has to be minus 1, 0, 0,
माइनस
0, minus 1,
yes
0, and 0, 0, minus 1, isn't it?
yes sir
And that matrix is an element of the group O3. Group theory products, mathematical. You can
yes
revise
sir
it. Yes.
hmm
So RP is an element of group O3, and determinant is minus 1. Okay.
माइनस 1
So now RP is multiple of identity matrix, right? And RP is equal to minus I. If you take minus common, it will be RP is equal to minus I. So
माइनस i
RP into R will be equal to R into RP. Okay.
p yes
Yes. What else?
yes sir and then sir जो इक्वेशन 2.19 को राइट करा जो ये rz phi equal to I cap minus I phi z j z cap by h cross theta केंदी ମାନେ ये
That is
expression
that,
केंदी
that, that, that is a generator matrix for that is a generator matrix no, sorry generator operator for total angular momentum. That
total
is a
angle
generator operator that is coming from chapter 1. Let me show you where. Yeah, if you come to page number 23,
yes sir
page number 23, here you can see, right? So for
hmm
infinitesimal small
yes
translation,
yes
Rz
sir
phi
hmm
is equal to I minus identity minus I phi z Lz divided by h cross, right?
yes
This is what actually we are talking over here also.
hmm
Yeah, that is what similar. I mean, they are Lz because orbital angular momentum. Here Jz because it is total angular momentum.
so it is a parity of transformation ମାନେ only xyz को minus x minus y minus z ରେ କେମିତି transform କରାଯାଇଛି ସେ ଜିନିଷଟା ଏଠି parity transformation
ପ୍ୟାରିଟି ଅପରେଟର ର କାମ ହଉଛି ସେ x y z ଯୋଉ ପୋଜିସନ ଟା ଥିବ ସେ ସାଙ୍ଗେ ସାଙ୍ଗେ ତାକୁ ପ୍ୟାରିଟି ଅପରେଟର ଅପରେଟ କଲେ ସେ ତାକୁ ମାଇନସ ଏକ୍ସ ମାଇନସ ୱାଇ ମାଇନସ ଜେଡ ପଏଣ୍ଟ କୁ ନେଇଯିବ। ମାନେ
ଆଜ୍ଞା
କଣ ଯଦି ଆମେ 3 ଡାଇମେନସନ ରେ ଚିନ୍ତା କରିବା ତାହେଲେ ଇଟ ୱିଲ ପାସ୍ ଥ୍ରୁ ଅରିଜିନ ଆଣ୍ଡ ଗୋ ଟୁ ଦ ନେଗେଟିଭ ଅକ୍ଟାଣ୍ଟ। ତମେ ଯଦି ଗୋଟେ 3 ଡାଇମେନସନ କୁ ଏକ୍ସ ୱାଇ ଜେଡ ଆକ୍ସିସ ରେ ଚିନ୍ତା କରିବ so there are 8 octants, right? There are 8 octants. ତେଣୁ ଯଦି ତମ ପଏଣ୍ଟ ଟା ଲେଟ୍ସ ସେ ପ୍ଲସ 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 ରେ ଅଛି ମାନେ ଏକ୍ସ ୱାଇ ଜେଡ ରେ ଅଛି if you operate parity operator it will take it to minus x minus y minus z.
अच्छा
Okay, but now the question is what happens to different, like what happens to position, what happens to momentum, what happens to orbital angular momentum, total angular momentum, or spin angular momentum. So then we can say whether we can determine parity and that quantity simultaneously or not. Okay,
yes sir
all right. So next is transformation of wave function.
mm,
Transformation of wave function. So you can see uh, psi x. Let me explain from here only. Psi x, which is the, that's a one-dimensional wave function. So spinless particle. So we are not considering. We are not. Just a second. So we are not considering any spin part. So it is a spinless particle. Okay.
mm, yes,
And so your psi x is basically equal to x psi. This psi is the state function. This psi is the state function. Once you take bracket with x operator, then it will basically give you psi x, the one-dimensional part. Okay. Now this is quite clear from your first quantum mechanics one, right? That x cap x bra dx integration from minus infinity to infinity is nothing but identity operator. Okay. This is it says that it is coming from basically quantum mechanics one. Okay. So
mm,
if we try to write pi psi operator, pi psychet, pi operator operating on psychet, pi operator operating on psychet, what will happen? I can write instead of psi, I can write I psi. Okay. I can just introduce one I over here, and that I can write this quantity. Okay.
अच्छा, mm,
So pi. So I should have this quantity on psi. So I can take that psi inside the integration sign. So it will look
yes,
like this one. Okay, clear?
yes,
Now, so pi will now act on x, pi will act on x, and x psi dx, right? Pi operating on x will give minus x, pi
yes,
operating on x state will give minus x,
yes, yes,
minus x, x
position,
psi. Okay.
yes,
Now it is telling making a change of variable. Variable टाକୁ change करिबा कौन करिबा x prime is equal to minus x. If we write x prime is equal to minus x, so dx prime will be equal to minus dx. Fine. तो ଏଇଗୁଡା को ଆମେ କଣ କରିବା ଏଇ ଯୋଉ ଦିଟା part को ଆମେ substitute କରିବା this equation. Okay. So minus x ଯୋଉଠି ଅଛି ସେଠି so it will become x prime state. x ଯୋଉଠି ଅଛି ସେଠି minus x prime state. Psi dx prime. Okay. Now minus infinity will become infinity, isn't it? Minus infinity will become infinity, and infinity will become minus infinity. कारण minus नहीं जो परा.
अच्छा अच्छा
अब ये जो
माने
minus sign
माने
change of variable,
इन्फिनिटी अच्छा
change of variable. So this minus sign is coming over here. This minus sign is actually coming over here. Okay. So what will happen is minus of integration infinity to infinity will become integration from minus infinity to infinity. So जो integration नहीं था a to b, if you take a minus sign, it will become integration from b to a, right? Using that property, okay, using that property, you can simply write x prime minus x psi dx. Isn't it? Now, if I multiply, if up to this it is clear, right? Now, what I will do, I will multiply one x cat, sorry, x bra over here onto the left. So multiplying x bra onto the left, so x pi psi will be equal to, so x will be multiplied onto the left. Okay, this is fine, isn't it? Now, So what is x psi? X psi is equal to psi x. ଆମେ ଆଗରୁ ଏଠି ପଢିଛୁ ଏଇ question ଏଠି. X psi will be equal to psi x. Right? So and this one x prime minus x psi dx prime. So this will basically give you psi of minus x. Psi of minus x. Okay. So what exactly we are getting? X pi psi is equal to psi of x pi psi. We are getting basically equal to psi of minus x. Psi of minus x is the space inverted wave function. Right? ଯେମିତି ଆମେ କହିଲେ x ଟା minus x କୁ ଯାଉଛି ସେମିତି psi of minus x ମାନେ psi x ର space inverted ହେଉଛି psi of minus x. ତାମାନେ psi x ଯଦି ଆମେ parity transformation operate କରିବା so it will go to psi of minus x. Okay. So that's what it is telling. So psi x mod square dx should be equal to psi of minus x mod square dx because that is the property of wave function, right? That is clear, Ella?
Yes, sir.
So now it is telling, let us consider that psi subscript pi is an eigenket of the parity operator. Is an
Agent.
eigenket of the parity operator. ଯଦି ସେଟା parity operator ର ଗୋଟେ eigenket ହେଲା
Sir,
ତାହେଲେ ତାର value କେତେ?
Eigenkate ମାନେ
Eigenket ମାନେ ଯେମିତି ତମେ ଆଗରୁ ଗୋଟେ ଇକ୍ୱେସନ ପଢିଥିବ h psi is equal to e psi ପଢିଥିଲ ଏମିତି କି?
ଏଟା ପଡ
So what is that? H is an operator, right? Hamiltonian. What is E? E is the energy. Okay. So that means an operator operating on a state function, an operator operating on a state function, if it gives the result some constant times that state function, that kind of equation is basically called eigenvalue equation. Okay. So now that means what? This is basically telling that if you do this is a state function. If you use this operator for a particular physical quantity, in this case it is Hamiltonian. So if you operate Hamiltonian on a state function, it will give you the value of energy. So it is a measurement state. Eigenvalue equations are nothing but in quantum mechanics, if you do a measurement on a state, you will get so you will use some operator to get a value, right? କାରଣ quantum mechanics କଣ କହୁଛି? Everything is the form of with ମାନେ state function, right? State function state ରେ ସବୁ information ଅଛି। ତେଣୁ ସେଥିରୁ energy କେମିତି ବାହାରିବ? Energy ସେତେବେଳେ ବାହାରିବ ଯେତେବେଳେ ଆମେ energy operator ଟା operate କରିବା। So in this case, energy operator is Hamiltonian. So when you operate Hamiltonian on a state function, that will produce the value of energy. Okay.
yes.
So that is basically the measurement step. That is basically the measurement step.
Match.
Okay.
Yes, sir.
So if you consider psi pi an eigenket of the parity operator. So if you operate a parity on a state function, so that will give you the value. Value means what? Either parity will be even or parity will be odd, right? Either it will be plus or minus ଆମେ ଯେମିତି ଦେଖିଲେ ଯେ position ଆଉ momentum case ରେ minus ଆଉ angular
It
orbital angular momentum total angular momentum spin angular momentum case ରେ plus.
plus.
So pi operating on psi pi will give basically equal to plus minus 1 into psi pi, right?
Yes.
What will happen if you multiply one x brown to the left. If you operate x brown to the left, so it will be x pi psi pi, which will be
Mm.
equal to plus or minus x psi pi. So x psi pi means it will be psi pi of minus x, psi pi of x ଆମେ ଯୋଉଟା ଆଗରୁ କରିଥିଲୁ କୋଉଠି ଏଇ ଡେଫିନେସନ ଯୋଉଠି ଏଇଠୁ ନେଇଥିଲୁ ଲେଟ୍ ଏସରେ 2.2.2 ହେଲା.
Yes, sir.
So now you can see that x pi psi pi could be equal to psi pi or could be equal to minus psi pi x, isn't it?
Mm-hmm.
But onto the left, this quantity we already have seen over here, equation 2.24. Equation 2.24 that is equal to psi of minus x. So that is
Mm-hmm.
why this quantity left ରେ ଯୋଉଟା ଅଛି x
Acha.
pi psi pi will be equal to psi pi of minus x.
Minus x.
ତାହେଲେ କଣ ପାଇଲେ ଆମେ psi pi minus x is equal to plus or minus psi pi x. Okay.
Yes.
So for even parity, it will be plus. For odd parity, it will be minus. For even parity, we'll just take the plus. For odd parity, it will be minus. Okay.
Yes.
Yeah. I suggest you just go through this part, this 2.2.2. ଏତିକି ଯାଏଁ ଥରେ ପଢିକି ଦେଖିଦିଅ ଯଦି କିଛି doubt ଅଛି ପଚାରିଦିଅ. Next, otherwise, we'll go to the parity of symmetry question. Okay.
Yes, sir.
Yeah. Go through it. ବୁଝିହଉଛି?
Yes, sir, ଏଠି ବୁଝି ହଉଛି।
Okay, good. Next is parity as a symmetry operation. Here, actually, we have already discussed this kind of thing in the past chapter also, that a quantity will remain invariant under any transformation if the Hamiltonian remains the physical quantity. এটা হচ্ছে যে কোনো ଗୋଟେ operator ହେଇପାରେ। ସେ operator ଯଦି ଆମେ ଧରାଯାଉ a dagger h a is equal to h ହେଲା ତାହେଲେ ଏଇ ଯୋଉ operator ଆମେ ନେଇଛୁ a dagger, that will keep the system same. That will keep the system same. So that means it is a symmetry operation. It is invariant under that transformation. So যদি pi dagger h pi becomes equal to h, then only we can say that the system remains invariant under parity transformation. Okay. Now, what is your Hamiltonian? What is Hamiltonian? Hamiltonian টা কোন? You can come over here to this part. What is Hamiltonian? Energy operator, right? Hamiltonian is nothing but energy operator. Energy operator means kinetic energy plus potential energy, right?
Potential.
Kinetic energy is how much? P square by 2m. P square by 2m is the kinetic energy, isn't it? So the first part over here is your kinetic energy.
Identity. Okay.
Second part is half m omega square x square. Half m omega square x square. If you have, let's say, a spring, if you have a spring system, then the potential energy is half m omega square x square, right? So you have px square by 2m plus half m omega square x square. Now m is the mass of the particle, so it will not change under parity. What will change? The position will change under parity, and the momentum will change under parity, isn't it?
Varieties.
So then, if I take this uh, quantity pi dagger h pi, that's what I have to find out, right? ଆମେ ଏଠି ଯୋଉ କହିଲୁ ଗୋଟେ quantity କେତେବେଳେ ଆମେ କହିବା invariant under symmetry operation କେତେବେଳେ କହିବା ଯେତେବେଳେ ସିଏ change ହବନି invariant under that operation or transformation,
Yes.
that will be equal to pi dagger h pi is equal to h. Pi dagger h pi will be equal to h. Okay. Now we are trying to calculate the same quantity. Pi dagger h pi. So the pi dagger ରହିଲା h ଜାଗାରେ କେତେ ଲେଖିବି p square by 2m plus half m omega square x square pi, right? Bracket
Yes,
open
sir.
କରିଦେଲେ କଣ ହେଲା 1 by 2m pi dagger px square pi plus half m omega square pi dagger x square pi, right? Now a quantity টা କେତେ? What is that quantity? Let me write it down. Pi dagger ଆମେ ପାଇଲେ କଣ? We got pi dagger h pi, which is equal to pi dagger p square by px square by 2m plus half m omega square x square pi, which is equal to pi dagger px square by 2m pi plus pi dagger half m omega square x square pi. So 2m will come outside 1 by 2m pi dagger px square pi plus m omega square by 2 pi dagger x square pi. So you have to find out this quantity and this quantity, right?
Yes.
Now what is pi dagger px square pi is equal to pi dagger px into px pi is equal to pi dagger px into identity into px into pi, which is again pi dagger px. Now here I can write identity is equal to pi pi dagger px pi. So this is equal to pi dagger px pi into pi dagger px pi, right? So this is equal to minus px into minus px,
Minus
which
bx.
is equal to px square. Okay, so similarly, pi dagger x square pi will be equal to pi dagger x into x pi x identity x pi pi dagger x, then pi pi dagger x pi. So this is equal to pi dagger x pi into pi dagger x pi equal to minus x, which is equal to x square. So if I substitute this one and this one square in this quantity, okay. So what I will get? I will get pi dagger h pi is equal to how much? 1 by 2m px square plus m omega square by 2 x square. So which is basically half, sorry, which is basically equal to px square by 2m plus half m omega square x square, which is basically h, or pi dagger h pi is equal to h. Okay,
Yes.
so that means the system remains invariant. System remains invariant under L2. Nani?
Yes, sir.
Now, if you take any other system, if you take any other system, then your this kinetic energy will be same, but potential energy will change, right? For any other system, uh, we have potential energy. Potential energy is Vx, right? Now, if V of minus x is equal to Vx, that means if the potential is a even function, then parity will be even. If potential is an odd function, if potential is an odd function, then parity will not be even. So then this relation will not hold good. Okay. ना हमको potential टा सब बड़ा symmetric हवा दरकार. V of x should be equal to V of minus
Yes,
x. चला बुझे हो.
yes, sir.
Okay. So I think with these thing you can uh, go through the rest part and see if you can understand or not. Okay.
Okay, sir.
Yeah. I'll possibly stop it here today.
Sir.
Yeah.
Okay.
Okay.
Thank you, sir.